measuring your concentration of your green lightning nitrogen end product. Okay, so the way that we're doing that is by TDS. So TDS and pH are the two things that we measure. We use this tool, the meter, to measure that. This is a multifunctional meter. It measures TDS, electrical conductivity, pH, and temperature. For our purposes, we're going to focus on the TDS and the pH side of things. The thing to know about these meters is that coming straight out of the box, they are typically not calibrated. They will say that they are, but in reality is they're not all that accurate. Our recommendation is to calibrate them pretty much immediately when you get them. The ways to do the calibration, or the things that you will need to do for the calibration, is the pH side of things, which they typically provide you pH powder to do the calibration. You just mix that up in distilled water, follow the instructions that they provide, and that will get you where you need to be. The other portion is the TDS calibration. To do that, you need TDS calibration liquid. They do not provide the TDS calibration liquid. That is something that is ordered separately. Okay, so this one we have calibrated and it is all ready to go. We have two vessels here with water in it. This one is straight distilled water. This one is our actual end product that came from the machines. Okay, so in this case we're measuring pH first, and we're just going to stick it in our machine, or in our cup, have a look. Our pH, it's coming around 2.70. So that's fine. Then we go in and rinse it in our distilled water, blow off the ends, and that is that. And then you will switch modes to go to ppm, which is your TDS measurement. In ppm, you'll stick it in there. This particular batch is sitting at 629 TDS, 641, so close enough. We finished measuring, and we are going to rinse it in our distilled water, blow it off, put the end cap, stick it back on, turn this off. That is the measurement aspect of it. When we talk about concentration, a rule of thumb that we're working on these days is anything between 250 and 500 TDS is the equivalent of about 3 pounds of N, or the same as, approximately the same as 2800. Okay, so you'll see that this stuff is actually a little bit on the high side. I would have no problem applying that to my crop, but that's just me. I recommend that you talk to your local rep if you're making anything that's a higher concentrate than 500 and see what they say. The importance of the pH side of things has to do with your storage and life expectancy on storage. Pretty much the rule of thumb that I go by is if you're between about 2.8, 2.75, 2.8 to 3.5, you're typically in a pretty good spot when it comes to your storage and life expectancy. We are currently doing experiments for determining life expectancy using various pHs and whatnot in various different storage vessels. However, I do know that if we were to put this stuff into storage to save it for next spring, it would be just fine by the time next spring rolled around. So the other thing that you need to be aware of when you're actually measuring your TDS, and it's just something to keep in the back of your head, is what was the TDS of your starting product, right? Your inlet water. Now, in this case, our TDS on this stuff came in at 9. So in reality, we went from a starting TDS product of 9 to now we're at 640. So we fixed about 630 ppm of nitrogen into our end product. So that is pretty good, and I would be satisfied with that, and anybody who is making that, I would be satisfied with that.